Los Angeles, and he's a board member for OWASP. He's also one of the reviewers for SANS mobile device, embedded mobile device classes. And he's here to talk to us about easy mobile hacking. So there will be a test at the end of these talks, and all the tests talks throughout the day. Well, not technically a talk, but there'll be 3 excellent goodies that we'll be giving away. So the speakers will have a couple of questions for you at the end of the talk. So listen up and you have a chance to win a great prize. With that, please join me in welcoming Aaron.
Just make sure you guys can hear me. You guys can hear me in the back? Good? Because I have 2 mics up here. Okay, I'm going to have to stay static from what I heard, so I'll stay here. It's kind of early for me. It's about 7 a.m. my time. I had to wake up, caffeine has my back, so that's the reason why I'm up here. So yeah, I'm going to be talking about mobile, let's say the offensive side of mobile assessments and the easy findings and within frameworks, within Android, within iOS. How many of you guys are, let's say, mobile pen testers or researchers or, let's say, web pen testers? Anybody do application security pen testing? Okay, a few? Okay, good. So I'm going to go through some basics so you guys won't be left in the dark. Some fundamentals between iOS, Android, as well as hybrid frameworks if you guys aren't aware what hybrid means or what that entails. So we'll start with a little dance for the morning. So again, my name is Aaron Guzman. That's my Twitter handle. I'll be tweeting out the slides afterwards, so no need to take pictures or anything like that. And then here is my email address if you guys need to contact me afterwards. I contribute to the OWASP mobile security project for the OWASP testing guide, as well as like the top 10 that's coming out. Other things, as Mark said, I was a technical reviewer for SANS Defending Mobile Application Security Essentials course. That's in beta. I'm the board member for OWASP Los Angeles, as well as the president for Cloud Security Alliance, Southern California. And then again, based in Los Angeles. So quite a ways to get here. Augusta is not an easy place to get to. It took me I left at noon yesterday, got here at almost midnight, and I was like, wow, just to go to Augusta. But it's been great. Yeah, definitely worth it. So again, we're going to go over the fundamentals, like I said, hybrid apps, some of the common findings that you guys can find within your next assessment or researching, or even to kickstart you to get your interest into mobile security. Very, very simple. I promise you guys will leave with something that you guys didn't know about, or even tools. Some of the tools I'll show you will help, let's say, with 75, 80%, at least with your Android assessment. iOS is more manual. But still, you'll leave with a good chunk of knowledge, which is the demonstration part, and then the tools that I use and the automation pieces. And then we'll finish up with questions here. So Android, it's purely Java-based or C++, but mostly everybody interfaces with Java for Android. The runtime for Android is ART, which is a new one, Android Runtime, or Dalvik VMs. So that's the Java virtual machine, is what converts the Java classes over to DEX bytecode to run on the Android devices, which we'll get to in just a little bit. But the core components of an Android device and an application are activities, intents, services, broadcast receivers, and content providers. Activities are just the GUIs that you see, the pages when you click, you have a new user interface, that's an activity. An intent basically serves as an action, so if you want to log into an application, you'll have an activity and you have an intent to log in. An intent you also check for like validation, whether it checks whether the user's logged in or not. Services run in the background, they don't have a user interface, so let's say downloading something that's in the background and the app still runs. That's what a service can be. Broadcast receivers are notifications. And content providers basically expose like the file system of the application sandbox, or let's say like a SQLite database for credentials if you want to share that between applications, shared applications. And the basics of the Google Play, let's say, review when you submit an application is the Google Bouncer. And what the Google Bouncer does is just analyze the application for let's say vulnerable or malicious activity. It throws it in a virtual machine. The application, it looks for anomalous behavior for, like I said, malicious or backdoors. It's not as stringent as the iOS App Store, but we'll get to that in a minute. And again, it doesn't go into strict low-level let's say application behavior, but it does look at some things like vulnerable libraries, like OpenSSL, for example. If there's an application utilizing a vulnerable OpenSSL library, the Play Store will flag that and let the developer know. The first place to look at, and basically like the core kind of configuration file within an Android application, is the Android manifest. And this is where, it's kind of small, you might not be able to see it here, but this is where all the activities, all the permissions are set, all the intents, the content providers, all the core components that I listed in the previous slide will all be defined within the Android manifest. And if there's any, they can also define custom permissions too, for whatever the developer is liking. You also see like secret codes. Let's say enter 1, 2, 3, 4, 5 in your phone, opens up a secret menu, and whatever the application developer defines. But this is where that is listed as kind of like the configuration file in the first place to look. So you can get an idea of what the application is running. And I forgot to mention, you can let's say open up to third-party applications these components, the activities, content providers, services, broadcast receivers, to a completely different application by exporting it. And when you export it, you'll define in here whenever the activity, so let's say the activity here, you'll define export equals true would be right here, and that's basically letting a third-party application access your activity. And then same thing for content providers, and same thing for broadcast receivers. And again, that's dangerous, right? If there's an activity that's post-authenticated after someone puts their credential in, and it's exposed to another application, obviously, let's say a banking application that you can see personal information, then obviously that's a big risk. So those are things you test for. If it's exported, you want to make sure that there are validations in place by the application. But again, we'll get to that in a bit. This is kind of just defining first place to look at within an Android application when you decompile an app. So here's the Android framework, and I'm not going to talk through the whole stack here, but I'm going to focus more on the Linux kernel and what defines, I guess for the most part, and separates a regular Linux kernel to an Android Linux kernel is the binder, which is for inter-process communication, and also paranoid networking. And paranoid networking basically checks permissions based off of the group ID and the socket to see if the application has access to send network traffic. So that's also defined up in the Android permissions within the Android manifest in the previous slide. But generally, just to kind of go over the Android framework, they're just Java classes that are used for the Android system, that are exposed like APIs basically, that let's say like Bluetooth, they're exposed via managers. So they have Bluetooth manager and Bluetooth service, for example. Those access the lower level kernel here to get access to Bluetooth. But again, there's Java classes. Java talks to the Java native interface, which is for native code. So it converts again from Java classes to bytecode and then over to native code. But again, just to focus back on here, binder for inter-process communication, meaning another app wants to access another application's data for whatever purpose, whatever reason, whether it's a application signed by the same developer or a total different app, just malicious app trying to get access to an exported activity, service, whatever it may be. It's all handled at the kernel level through binder. And it's kind of like a proxy between process A and process B, and I'll show you in just a second, but what it checks is the process ID and the user ID. So every time an application is installed within your Android device, a user ID is defined or is set, a unique user ID. So that's kind of the, let's say, the sandboxing. And again, we'll get to that in just a second. But here is kind of how binder works. And again, like a proxy here. And it checks between, again, the process ID and the user ID to see whether they have access or the correct access and permission to talk to each process. So process A talks to the proxy, which is basically an interface between a binder. And this is all done within the kernel. And again, process B also wants to check that as well, wants to see if it can get access to process A. And the binder is what's doing the verification here. And then it's obviously giving the OK because now process B can access process A's information because it has access. And let's say the permissions are defined correctly. And so all permissions within an Android device are all defined within an XML file. Everything's kind of a compiled XML file. So if you go on an Android device and you do, let's say, via ADB, Android Debug Bridge, you can get command line access. You can do PM list to list the packages. So package manager is PM. And then service list, service space list defines every service that's defined within binder. So any service that can talk inter-process communication is defined as a service. It's kind of background information, but again, binder does the heavy lifting for inter-process communication within Android. Just keep that in mind. And binder is based upon open binder. So again, Android is kind of open source at its core, and a lot of components are based upon open source technology. So again, process ID, just remember binder, process ID, and user ID is what it checks, and that's at the kernel level. So the sandbox, and I kind of mentioned it already, and it's similar to the Linux type of permissions. Again, discretionary access control, not mandatory access control, meaning mandatory access control can be more stringent, like SE Linux, for example. Discretionary means if you allow the user ID 12345 to access 9876, then that'll be allowed if you allow it explicitly. Otherwise, by default, it's not allowed. So again, it's separated by user IDs, and these are both different applications, as you can tell, different user IDs, and they can't access each other's information unless they explicitly allow that. But by default, definitely not. And this is within the application sandbox of Android applications. So a database could be a SQLite database, internal storage, could be cache, whatever it may be. Preferences is also another XML file, can be used for, I see it for a lot of things. It's usually for insecure data storage. I see it more for that than anything else where people are storing passwords in clear text. But we'll look at that in just a bit, so don't worry. But if you have an application, Android application, the file extension is APK. And within the APK file, it's just a zip file. And if you rename the the APK to a zip, extract it, here's the file structure, the basic file structure. That's actually supposed to be the Android manifest. I typoed that. But again, Android manifest is supposed to be here. Assets, classes.dex, and this is the bytecode that the Dalvik VM runs, basically binary. So this is kind of the basics of how Android works with permissions, with components, and basic things to look at when you first get into and decompile an application. But again, this is just an idea so you guys have a foundation to understand what I'm going to show later on. So we'll jump to the iOS side of things, where it's based upon the primary language is Objective-C, and it's a messaging language. And if you were to use a debugger, you would hook Objective-C message send, and that sends it over to basically to be processed by iOS. There's also Swift as well. The only app that I know that's completely written on Swift is Lyft, and it's written in layers. And again, it exposes APIs. iOS does a good job, or Apple does a good job of providing the documentation for that. But primary language is Objective-C. And then the App Store review that I noted earlier, again, much more strict. It takes about a few days, 2-3 days, for an application to be deployed. And you got to keep that in mind as well, because with Google, same day you upload it, it'll be published. But with iOS, it's kind of a pain point for some people, or some enterprises or manufacturers, and that's partially the reason why, obviously depending on usability, but that people choose mobile hybrid frameworks. And again, we'll talk about hybrid frameworks in a bit, but you don't have to resubmit it over to the App Store in order to make changes or updates, which is kind of scary. So the equivalent to the Android manifest in iOS or in iOS applications is the info.plist. And this is the Xcode version. It's really just another XML file when you decompile an app. And I believe I might have in the next slide, but I'm not too sure. But what's defined in here, and this is from a Kivo app. So I do a lot of IoT research, and anything that has a mobile app and it's connected to the network, I'm going to look at it, whether it's my car, whether it's my lock, whether it's my light bulbs. But this is my new toy that I got. But within iOS and the info.plist, even here, Apple requires an application to define why it needs a permission. So this one specifically is always on, always use your location when the application is running, or even when the application is not running. And it defines a reason as to why it needs that permission. And Apple reads this. Otherwise, they'll send it back to you and ask you why you need these sort of permissions and for what purpose, and why does the application have to function that way. But for inter-process communication within iOS applications, you have URL schemes, and not like IPC, but with URL schemes, it's like, HTTP://. In this example, it's Kivo:// or Facebook will have theirs defined here as FB:// in order to call it. So any application can theoretically call another application within an iOS device if they use this schema, and it's up to the application to provide verification and validation for inter-process communication. But again, kind of permissions are set theoretically for iOS here in the info.plist, as well as IPC, inter-process communication, communicating with other third-party applications within a device, and then also any type of basic, let's say, what the device is or what the application is targeted for, what device. So this one specifically is iOS 8.3 or 8.4. I'm sorry. So that way it's only targeted for newer type of APIs. But again, first place to look, again, similar to Android manifest within the iOS application. And again, I'm not going to go through the whole thing here as far as the architecture of iOS, but I'll note a few things. Secure boot chain for Apple iOS, so it's basically burned into the images, the iOS images from the factory. I'm also going to note secure element and secure enclave. Secure element is where Apple Pay, any type of financial transactions, and then secure enclave would be Touch ID, keychain, which is secure storage, which is any type of credentials, tokens should all be stored within the secure enclave. And we'll get to the sandbox in just a minute here, which is the next slide. But again, secure element, secure enclave are basically secure storage, while secure enclave, secure storage for any type of credentials or sensitive info, even if it's not credentials. And the only way an attacker can get access to that is if the device is jailbroken. So sometimes if there's something really sensitive, some people usually hash or encrypt and then put it into the keychain. Just something to keep in mind. So the sandbox within, doesn't look too great, but the sandbox within iOS, they're unique home directories, again, similar to kind of Linux-based a little bit. And they have their own data container, which is totally separate from the bundler container. And then if the application has iCloud features enabled, you also have another container for that. But these are all separate directories as well, unique separate directories at that, when the device, when the application is installed onto the device. So the file extension for iOS applications end in IPA, so app.ipa, and again, zip files as well, rename it to a zip. And here's kind of the basic structure. Any type of application that you rename to a zip and you extract, it's always going to have this payload. So let's say I decompile or I extract that Kivo app. I extract another, let's say like Instagram or something. I will have Kivo.app and I'll have Instagram.app in this same folder, in this same payload folder. It'll be extracted into the same exact structure. But where the meat of where you want to look is inside of this directory here, the .app folder, is where the application binary is at. So by default, when you submit an application into the App Store, the apps are encrypted by Apple's DRM. It's called Fairplay DRM. But let's look at it from a pen tester's perspective, where a client is going to give me an IPA file. It's not going to be encrypted. So again, it's just a zip file. And from there, I can just look into this directory, drop it into IDA, find the binary, drop it into IDA, and then I can see all the client-side code. Very, very simple, not too hard. And I'll have a couple examples afterwards. But these are kind of just other metadata, but I kind of wanted you to just take point here is where this is the main item to look at within the decompiling or extracting of an iOS app. So let's talk about hybrid frameworks. Anybody heard of hybrid frameworks before? A few. Okay. We'll talk about it. So what hybrid is basically iOS, the web, and Android. Cross-platform, works between all three. You can have one code base. Obviously, that doesn't sound too great. Well, at least for me, because that exposes HTML5, JavaScript, and then other native vulnerabilities, native API vulnerabilities within each platform. But again, some of the keys about hybrid is you can update without redeploying, because it's JavaScript. You own the web server, you own the application server. And all it is just what's called a web view. And what that web view does, basically, it's in-app browser, an in-app browser for an application. And it basically dynamically runs code, executes code. So like a web app, like I said, HTML5. And HTML5 has its own issues, which I'll note in just a bit. But a lot of these applications are heavy on JavaScript. And with that, you also have to keep in mind that people think they can store secrets in JavaScript. Like, you can't decompile it. It's in clear text. But again, something to note. And one code base here. And it's odd, and another huge area that needs to be researched, I just don't have the time, is each hybrid mobile framework has its own marketplace and plugins. And whether they provide code reviews or not, or security reviews, which I doubt, they all have their own marketplaces. So think about Google Play, think about App Store, Apple's App Store. But now these frameworks have their own marketplaces with thousands of plugins and thousands of apps to kind of piggyback and third-party code that's not even being reviewed or researched. And even to upload that is very, very simple. And I'll talk about one instance for a mobile framework a hybrid framework that we'll talk about, one of the most common ones. And I was talking about WebView, but it basically renders the web page, and you could either use WebKit or Crosswalk. Two different web runtimes is what it is. The native code, like I said, you have your own native vulnerabilities. Objective-C with iOS, there are plenty of, let's say, for the URL schemas, for the inter-process communication, there are legacy APIs that have since been deprecated, but are still being used by applications that doesn't validate certain parameters, for example. Swift, Java, C, C++ with native, you kind of have more control over the application. Then, like I was saying, with HTML5, you have your own issues with WebSockets, local storage. These are basically on-disk persistent storage. People store cookies onto an iOS device into local storage, which is on disk and can never be deleted. Not even by the application. You have web workers, access to the file system via the file system API, WebRTC, real-time communication for chat, video communication, and there's plenty more. But again, this opens up a whole new attack surface with mobile hybrid frameworks. So the most common here is Apache Cordova, which is also known as PhoneGap, and a lot of these other hybrid frameworks piggyback on Cordova. Big enterprises, corporations use Cordova, whether it be banks, whether it be private companies, public companies. And again, it's most common, and you can choose the web runtime, but it chose Cordova recently switched over to Crosswalk. So, and again, I talked about the plugins here for the mobile hybrid frameworks and the risky things with it, but they actually call it out within their documentation. So it says a plugin is a package of injected code that allows the Cordova web view within which the app renders to communicate with the native platform on which it runs. So it's basically cross-site scripting, JavaScript injection. That's what a plugin is. So you can name a plugin whatever you want, calendar.js, and maybe do some legitimate things, but also do some fun, mischievous things, spyware things. But it's so easy to publish a plugin. They give you step-by-step instructions, and it's up into their repositories. NPM is what Cordova uses for their plugins. And again, very, very easy to publish a plugin within Cordova, within the ecosystem. And again, it's injected code. And it's going to run within the web view. So again, like a web application, same thing. I think of it as cross-site scripting. And again, the review process with this is just, there's basically none. And it's kind of just on your own due diligence is what they're looking for developers to do. But again, who does that? Here's the code review process, stuff to look for. Test for error conditions, explicit errors for bad user input. I don't know what that is, but have labels. But there's not much to it. It tells you how to submit it. It's basically the process, but there's no denying, no going back to developers because NPM is its own entity and they're not in charge basically of how Node.js or JavaScript runs. And again, a huge area to be researched. If anybody has the time or anybody wants to work on it. This is just for Cordova. Every other mobile hybrid framework has their own kind of plugin and marketplace. Literally, like you go into and you just kind of click install and it goes into your application. Very, very simple. An example of when, let's say like Node.js, for example, there was a developer who basically took their dependencies or their packages off of NPM because of, let's say, Kik. I think Kik, the messaging service, had some kind of copyright issue with how that repository was named. So the guy got mad, took off his repository, and all his code did was 17 lines of code was basically add padding to the left side of the page, and it broke everybody's build because Node.js and JavaScript is dependency heavy. But Node.js runs on NPM as well. So there's no verification and again, validation or anything. So anybody can kind of submit and take these injected plugins or JavaScript code. And you can do some pretty good damage. This one was just taken off a repository, but I could only imagine if you're running some malicious code, what can happen. Again, for the NPM registry here. And here are some of the advisories just within the year for Cordova. This was a remote exploit of secondary configuration variables in Apache Cordova on Android. And again, rated as a high in severity. This one was last September, so last year, another plugin vulnerability. I'm not going to go through them. I'm just going to show you just within the last year how many vulnerabilities and how many are high and remote code execution, for example, that these hybrid frameworks expose. That's a medium here. You can't really see it much, but again, just within the last year, this one was in April, and this one was also a high. Bypass of access restrictions in Apache Cordova iOS. Another high here, Cordova cross-application scripting via Android intent URLs, cross-site scripting, in other words. This is within the framework itself, so keep that in mind. Bet you the enterprises once, how many times have they updated their whole framework? Probably not much. So I'm pretty sure the security team is doing this once in a while once they know they're running Cordova. If any of you guys know you guys are running Cordova now, you're probably not too happy, but and again, even with the web runtimes, there's also vulnerabilities. So Crosswalk has their own OpenSSL. This is from Google Play Store, but it's for Crosswalk as well. Another big common or big player in the game is for hybrid frameworks is Xamarin. And Xamarin is owned by Microsoft. And what they say is anything you can do is in Objective-C, Swift, or Java, you can do with C# in C# with Xamarin. So you basically write C# code, and it converts that to Objective-C, to Swift, and to Java, which is interesting, right? Like I'm pretty sure there are some issues there. And it runs on the devices, it runs Mono, which is the .NET runtime for Xamarin applications. And then for Android applications, it runs an ARM executable, and it's a ahead-of-time compilation is what it is. So Xamarin also has a free and enterprise version, and I did note, again, that has another marketplace too. But within its free and enterprise versions, they have their own IDE, and within their IDE, it's like a fork of Visual Studio because again, Microsoft owns it, but it also has specific Xamarin functions as well. So one cool thing that I found, this is back in 2014 is when this was raised, but to keep or to store passwords within an Android application, to securely store it is within the Android key store. And for Xamarin applications, they have their key store hard-coded into the Xamarin framework. So anybody with a Xamarin application on an Android device, an attacker can decrypt all their passwords for Facebook, Google, or anything that uses this Xamarin.auth plugin or component for Xamarin. So this guy says, back in 2014, instead of using hard-coded key store password, the application should provide its own from a safe origin. Otherwise, the Xamarin.social.accounts key store and all apps that Xamarin.auth components that use Xamarin.auth components can easily be breached just by looking at the source code on GitHub. Because this is open source, by the way. It's all on GitHub. And here's that string, that amazing string here that you can use to decrypt the passwords within applications that use Xamarin.auth. So I first started looking at this in April. I gave this talk back at CactusCon, or a similar talk at CactusCon. And just yesterday, I went and took a look back, and there's some activity back in June. And this guy was saying basically, I think that this pull request should be reviewed, even if it's past 2 years from its initial proposal. And the guy's saying we're working on it in June, and then supposedly it was merged, but it's not merged. I already looked at it, but it's still not merged into master, so it's still an issue. And this is July. This is not too long ago. So while I was clicking around researching this, I was laughing because I saw this post of this guy who found the same thing, and this is in July as well. He's like, oh, I wanted to store some sensitive information like refresh tokens in the key store. I was going to use, another key vault storage plugin. And in their Xamarin.auth library, which leverages the key store, they have the password hard-coded. He's like, what's going on? Am I missing something? Which is not. It's in plain text, but all of a sudden I thought it's funny that people are kind of taking note after years of this being a vulnerability. But again, anybody who's using Xamarin on an Android device are pretty much at risk for their credentials to be compromised. Another thing within Xamarin, with Android 5.1 and below, Xamarin uses a DLL and it drops it, or it had dropped it into the SD card. And the SD card is world writable, world readable. And what someone can do is basically overwrite that DLL file and backdoor the application. And that's exactly what people did. So, and then developers have to rebuild their application using Xamarin for Android 5.1 or newer. And I think most enterprises target Android 4.4 right now. So, and this was last year. Here's another one. It's Telerik App Builder. It's one of those drag and drop type of applications. And it uses backend as a service. So let's say MySQL, MS SQL, things like that. You basically outsource that to Telerik. And for me, when I see easy, I know there's some issues there. So having a look at their documentation, and it piggybacks on Cordova, and what they advise to their customers is they want everybody to deploy via their app store, so that way they can have full control, 100% full control on who has the ability to install their app, which is not true, for one, and for two, iOS, are they going to encrypt those applications? Is it going to be that much easier for attackers to get access to those apps? And also, even the malicious behavior, the libraries, the backdoors, and all that, I guarantee you that Telerik is not throwing those into a virtual machine and analyzing that type of information. They're not Google. But also, to kind of summarize here, they want, if you're going to store secrets, they're advising you to obfuscate and minimize the JavaScript code, which you can just Google deobfuscate JavaScript and it'll do it for you. So obviously that's not a solution, but they're suggesting or advising their clients to do so. Or just load JavaScript remotely, because you can't proxy the information at runtime, right? Being sarcastic, you could proxy it, look at the HTTP response, and then view everything it's sending back to the application. So never store secrets in JavaScript, hard-coded. Never store secrets on the client side. If you're going to store secrets, store them in the key store for Android or the keychain for iOS. And this was from a post here within their, it's Ionic. Again, Ionic uses Telerik's App Builder, but there was about like 83 or 84 like thumbs up, like, hey, this is good advice. Use it. And they have a kind of a general disclaimer as well when you use Telerik. And it says, Telerik does not enforce any security permissions and will invoke any user-supplied data object code and process regardless of whether it is trusted or not. So, they said it. One of the last ones is Genexus. I've seen Genexus only in kind of Latin America area within applications that are used within Latin America. And again, it's one of those app builders, drag and drop type of things. And it has various compatibility with various languages, C#, PHP, and other backends as well. Some of them are specific. That's kind of why I put that out there. And what it uses for authentication and authorization is OAuth. How many are familiar with OAuth? Okay, definitely a lot more. Sweet. Because that's going to be a huge topic. And some of the insecure defaults, everything's defaulted over HTTP. Even their REST interface to call OAuth tokens all over HTTP. And they also advise to hard code your client's secret within your application binary, which is not a good idea. We'll talk about that in a bit as to why it's not. But once you have the secret, the client secret, and the client ID, you could basically get granted an access token or a refresh token. But Genexus only uses access tokens, so they're long-lived. So access tokens are something that say that Twitter uses. I don't know, when the last time you guys logged into Twitter or Facebook or Instagram? Probably like never, unless you like had a reinstall or something like that. But again, long-lived. You don't have to have username or passwords. All you have to do is grab his client ID and client secret, and you're good. You can get refresh tokens. So common findings. I'll start with SSL and TLS issues. Always, for the most part, always, unless they're pinning. But these are the things I look for within iOS. If they're using a certain library like AF networking, it doesn't verify or validate certificate chains. You can allow all HTTPS certificates. Sometimes you'll see that for debugging purposes, but they'll deploy it to production forgetting. Maybe, I'm hoping forgetting. I don't know. And they're turning off SSL pinning mode. SSL pinning is basically only allowing the application to communicate with a server that has either a public key or a domain name, or just that certificate only is what SSL pinning kind of enforces. So these are when I drop it into Hopper or IDAPRO, for example. I'm looking at client-side code and I look for this before I even install the application. I'm going to statically analyze, and then I'm going to verify and validate during runtime. So again, more APIs that I look for within iOS. Okay, I got to hurry up here. And here's a new one for iOS 9 and above. Allow arbitrary loads. This is the plist file. It's basically with app transport security, it only enforces TLS 1.2 and forward secrecy cipher suites. So if you're a bank, something like that, you'd want to enforce app transport security. But in this case, they're disabling it. iOS 9 and above, it's default. I'm going to kind of go through these quickly because I want to show you the demo. These are the Android APIs, vulnerable APIs that I search for as well. This is easy. When I get the application, I decompile it and I open up in JD GUI, and I'll show you in a bit. Something to note, within Cordova, Cordova doesn't support true certificate pinning. So if a mobile app or a banking app is using Cordova, something to keep in mind. And insecure data storage is everywhere within mobile applications. That's what I see the most. That's what I find. Whether it's personal information, encryption keys, secret keys or values, passwords, OAuth tokens, definitely. SQLite databases, Realm databases, which are iOS specific. Binary cookies, cache, and temp directories is where I look for those. You cannot see this, but this is a client encryption key here, client secret, here API keys, and this is all within a JSON file for an iOS application. This is something that a tool won't find. This is when I'm on the file system of, let's say, my iPad, and I'm just checking within the bundler container I showed you guys in the sandbox earlier. I looked through everything. I'm nosy, so I happened to find this, and I was like, sweet. Client, encryption keys. This is like server encryption keys, like private keys, not even public keys. Here's another one. Again, I'm in the container here, the bundle container for the application, and again, another instance of a private key being stored within an XML file in clear text. This is while the application is running too. So the device is jailbroken, so that's how I'm able to get access. SSH in. And by the way, this is their own encryption. I don't know why they try to encrypt their own things instead of using the platform security encryption mechanisms, but yeah, that's why I said but why. So Android side of things, again, same thing, username, passwords, all the secret values. Shared preferences is the difference here. It's an XML file I noted earlier. And people or developers seem to think that's a secure location because it's within the application sandbox. But within mobile security, if somebody gets a device, let's say it gets stolen, lost, and it's stored within the shared preferences, you don't have to have a username or password if credentials are stored in there or if tokens are stored in there. Here's an instance where the access keys, let's see, the access token is being logged to the console during application runtime. So within Android, you could do ADB logcat and just watch all the logs, or you can grep for the specific application. But in this instance, they were logging the access token as well as the refresh token. And here's the shared preferences file where they're storing the access token here in clear text, and I can just pop that into another Android app, the same thing into their shared preferences, and now I have access. Easy, refresh the page, no username or passwords required, and then I'll have access forever, basically. Here's a funny one with SQLite, SQLite database that basically one of my clients decided to clone their production database into a SQLite database, which included usernames, passwords. Here's the usernames, here's the passwords, and then the hash passwords. And then in other tables, it showed like emails, other people's emails. It showed their Windows SID. It showed everything, and I was like, "What is going on?" Here's just a note with about OAuth, and they describe it in their RFC. But it's the threat of obtaining client secrets here. And let me see if I can, here's the attack here. Obtain secret from source code or binary. And that's the client ID and client secret I was talking about in order to retrieve an access token. So the client secret is used to authenticate the identity of the application to use the services API when the application requests to access a user's account, and must be kept private between the application and the API. So if it's not private if it's within the client-side code. In my world. Here's an instance in real life where Samsung SmartThings lock within their application binary hard-coded their client secret, and again, just like the other apps I showed. But now people are able to get access to the front door because of that. And again, I kind of highlighted here, client ID and client secret. At this point, we had everything we needed to get our own OAuth token. And then you have access to someone's front door. So that's cool. Like James Brown says. I'll let you guys read it. I want to read it out loud. More instances. This is with Genexus, obviously, where they hard code the client secret, client ID, and obviously rename this. But these are the endpoints in which you authenticate to. And again, clear text. It's supposed to be a secret. Ooh, okay. I'm going to get to demo real quick because I'm running out of time. More secrets. Perfect. I have one running here, and it's called Mobile Security Framework. It's Python-based. I'm just running it for you guys. I believe I have a scan here already. I'll show you my friends from Subaru because I seem to be picking on them lately. If it runs. If not, we'll go to Quark. Quark's Python-based as well. And Quark was created by the LinkedIn guys. So it's asking us to provide an APK, the path of the APK, in which I will, and I didn't even separate this, but close your eyes, guys. I think I have it here. Demo app's perfect. Here's a manifest file. This is for Subaru. I gave a talk at IoT Village at DEF CON, and I was able, again, their client secret, client ID, I was able to get access to my car based upon that forever, to unlock my car door, locks, everything. But what can't see, it looks kind of weird. I think it's the terminal. But what Quark does is get 3 different Java decompilers, JD Core, ProYocon, and CFR, and aggregates the best results. And it's gonna statically analyze, and it's decompiling right now. So we'll hop over it. Hopefully this is running. Cool. So there's mobile security framework. Obviously it runs responsive, so in Twitter Bootstrap. Shows the main components here. Activities, services, receivers, providers. Also Java as well. I'll show you guys this real quick, or just a second. But this is on GitHub, free tool, tells you about permissions. Gonna have to go quickly here. But anything that looks like HTTP connections or anything that has this type of activity or API, it categorizes it for you. What I always look for first is passwords. So in this case, see if there's any password, I see a URL. It turns out there's a local web server that starts up. But here, I'll go into the fun stuff. You could do secret. Oh, looks like, here we go. Consumer key, secret, hard code into the app. Okay, wrapping up, guys. But again, very, very easy. And this is also for iOS applications as well. Not as in detail, but you can see classes within an application, and the plist files as well. But the other tools I was going to show you, aside from Quark, is Android Bugs Framework, Python-based as well. Real quick, just give me 1 minute. There's the file. And this is really quick, and it, again, statically analyzes the application, the client-side code of the application. Very, very quick. It's going to spit out a text file, and this will be my last one. But if you guys have any questions or want to know more, just hit me up, or I'll show you guys afterwards. Very, very easy. These tools, again, do like 80% of the job for you. And this is before you install the application onto your device. Okay. 1 minute. Let me just show you the file real quick and what it looks like, and then we will close out. Just SSL checks, vulnerable methods, dynamic code loading, anything stored in external. Okay. Let me go to my final slide and using Google Slides, by the way, so it's taking some time. Come on. Okay. So you guys can read that real quick. Okay, thanks, guys.
First thing we got is a copy of Android Security Internals, and it does guide to Android Security Architecture.
It's a great book. I've read it. Yeah. What does binder check for? What permissions or what? Anybody know? Yes. No, what does it check for? That's what it is, but what does it check for? Like, yes. That's good. Who said that? Cool.
All right, I got another book here. This one is iOS Application Security.
That's a great book too.
For hackers and developers.
Yep. what is the iOS application sandbox? How does it sandbox applications? Simple. Let's think of it as Linux.
They're all separate directories?
Yeah, they're all separate home directories.
All right.
Cool.
So also for the drawings, I got some ticket numbers. You guys can check your tickets. There's first thing is for a